So this video is just about some questions that are to do with networks. So this is from one paper that was in 2018. So the first question is describing differences or explaining two differences between a LAN and a WAN. We'll notice that there are 4 points, so we've got to try and make four points about this. So we know something about a WAN, which is a wide area network, and a LAN, which is a local area network. And normally, the question they ask us is, what's the difference? And here is one difference. A WAN is a large geographical area. Linking remote sites. And a LAN is a single site or small geographical area. And that's good. We've made our point there, which is probably the first one we thought of, because that's often what we define as the difference between them. So now we need a second difference. That there are actually, of course, lots of differences. There's lots of things we could say. It's probably worth thinking of one of them that is easy to come to mind. So the one that always comes to mind for me is that WAN networks are often publicly owned or often public networks using encryption. LAN is often owned by just one organization. Not always encrypted. And we've said enough there to get the marks. Now, of course, we could have said something about speed. So LANs are usually quicker. And that's generally to do with the fact that traffic is easier to manage on a LAN because it's owned by one company, whereas if you've got a wide area network like the internet, for example, then there are multiple users. We don't know who's going to be on at what time, and sometimes the network slows down as a result. It can be that LANs are better protected from viruses, excuse me, and also from peak use times, whereas WANs are not. So we could say something about that. We could talk about the fact that wide area networks often have heavier traffic, but it's better to stick to just some ideas that we can remember. So idea one is the idea of this geographical network. And we know this, this is one of our things that we've looked at as a definition. WANs, large geographical area. LANs, single site or a small area. And then we've looked at WAN networks are often public and they use encryption. So we've actually almost made 2 points here. And LAN is often owned by one organization and not always encrypted. So we've made 2 points, good points on those. And we've also mentioned the idea of speed, just because that's an extra thing we could have talked about. So that's the differences between a LAN and a WAN. So now another question that was follow up on this was about protocols. So two protocols, HTTP and HTTPS. I explain why HTTPS is often used rather than this one. Well, HTTPS is encrypted. So is more secure. And data cannot be read without the encryption key. So we only went for 1 mark on this, and 1 mark seems fine to me. We'd have stopped at HTTPS is encrypted. That bit there, that would have got us the mark. We didn't need to go any further. So some other questions. So here's another one. The application layer and the network or internet layer are 2 of the layers within the TCP stack. What are the names of the other 2? So we can't have application and we can't have network, but we could have transport. And we could have data link. So those are the other 2 layers that we've looked at. So we've got application, transport, internet or network, and data link layers, and they're the layers that we looked at in the TCP stack for GCSE. So that was just straightforward remembering what they were. What is the purpose of the network layer within the TCP IP stack? So the network layer, this is where IP operates. So IP operates at the network layer, Internet Protocol. And so first thing we write down is routing, because routing routes packages or packets across the network. That's the primary role. And then because it's the IP layer, it adds IP addresses to packets. So we've got 2 ideas there for 2 marks. So routing is always the first one to come up with because that's the main thing it does. We needed a second mark in this case, so adding IP addresses, and that allows it to ultimately find the recipient for the message. So the last one on here is explaining how MAC address filtering works. Well, a MAC address is built into a device. So a MAC address is on a device, it's put onto a device in the factory. So it's a unique identifier for that device. So we could say that first. So we could say each device has a unique MAC address. And that'll get us a point for saying that, but we do need to talk about how this is going to work. So we could say that there is an allow list or a block list, and we could say that MAC addresses are added to one of the lists, and the network, possibly the router, looks at the lists to allow or deny access as appropriate. So we've written a little bit more than there were lines, and that's fine. Don't worry about doing that. It's often good to write a bit more. No problem to do that. So we've got all the marks we've needed there. There were 2 marks. So we've talked about having a unique MAC address, talked about allow lists or block lists. We've talked about how those addresses can be added to the list and how the router can look at the list to allow or deny access whichever list they're on. So that's MAC address filtering. So that's several questions there about networks and about how the protocols work, etc.